All right, so today we're going to start solving one-step equations. So again, an equation is a math sentence that has numbers, operations. If it's algebraic, which is what we're going to focus in on, it also has variables and an equal sign. Now, because it has an equal sign, we can actually solve it, meaning that we can isolate the variable or get the letter completely by itself to determine what its value is. So to do that, we first decide what operation is acting on the variable. We practiced that yesterday. And then we're going to use those inverse opposite operations on both sides of your equation to undo it. And again, get that variable by itself. So if we take a look at this first example, if we're asked to determine, again, the first step is determine what operation is being shown. In this case, you should see over here on the left, here is my side with the variable. It is addition. So to undo it, we know the opposite of addition is subtraction. So we're going to go ahead and subtract 7 on both sides of our equation. Now, you probably have seen in math, a lot of teachers draw this vertical line right down through the equal sign. I think that's very helpful just to identify the left side of the equation from the right side of the equation. So when you use your inverse operations, we need to make sure that we're fair to both sides. So again, we're going to subtract 7, use that inverse on the left-hand side, and then also subtract it on the right. Because when we go ahead and perform 7 minus 7, it's going to disappear, right? Its answer is 0. So you don't need to write it down. It's just kind of we cross it out. And then we have our x, which follows right on down, and we rewrite it. So x is now the only variable or the only term left on the right or the left-hand side. And then when we perform the operation here on the right, we have 32 minus 7, which gives us an answer of 25. So x is going to be x we've determined is the value of 25. Now it's important to check your work just to see if your answer is correct. And one-step equations, very easy to do that. What that means is, again, we said x is equal to 25. So we kind of use that evaluating skill that we looked at a lot in the last unit. So here was my original equation. And we're going to take that 25, our answer from above, and we're going to plug it in for our x. So here is our x right here. We're going to replace it now and evaluate it as if it was 25. Then if we simplify here on the left-hand side, 25 plus 7 gives us 32. If I just bring down my answer or my value from the right-hand side, it's 32. This is a true statement. 32 is equal to 32. So it validates to you and lets you know that your answer is correct. All right, taking a look at example B. So there are 4 operations, right? So we're going to take a look at all 4 operations in the equation. So if I look at example 2 here, here's my original equation. So you have to kind of think of these steps in your head, determining what operation is being shown. So again, if I look at the left-hand side, here's where my variables. It is subtraction. So to undo it, I'm going to use my inverse and I'm going to add on both sides. So I add 21 on the left and I add 21 on the right. And again, the reasoning for it is because when you go to do the computation, using inverses eliminates that on the left-hand side and gets our variable all by itself. Performing the operation on the right here, we have 10 plus 21, which gives us 31. So this is our proposed answer. X is the value of 31. So again, checking your work is super easy. You can do this in the calculator, but it's also, again, a good way for you just to make sure that you got your answer correct. That's the nice thing about equations. You can check your work. So again, here's my original problem. X minus 21 equals 10. If I plug my answer in for x, so see, here's my x. I'm taking it out and putting in a 31. Performing the operation here on the left, 31 minus 21 is 10, which on the other side is 10. So again, this is a true statement. You know your answer is correct. All right, example C. So here's my original equation. 5x equals 25. So looking specifically on the side with the variable, thinking yourself, okay, what operation is being shown between the x and the 5? It's multiplication. So my opposite, or my inverse that I'm going to use, is I'm going to divide by 5. And remember, in math, we use that fractional bar to show division. So we're going to divide by 5 on the left. We're going to divide by 5 on the right. Now again, when we're looking at using inverses, 5 divided by 5 is going to give you 1. Now 1x is the same as 1. I mean, it's the same as x. So you really don't have to write it. because that is the same thing. So we, again, kind of use that method of crossing it off because it eliminates itself. 1x is equal to x. So we're just going to rewrite, drop our x down, and we have x. Now, performing the operation on the other side, 25 divided by 5 is going to give us the answer of 5. So again, this is our proposed answer. The x is equal to 5. So taking a step and checking it, 5 times x, we said is 25. If we plug our value in here, 5 times 5. Now again, you could also write it with the dot, but shy away from the x because that looks like a variable, right? The other method is what's shown in the problem here is that you can also use parentheses to indicate multiplication. So solving through, 5 times 5 is 25. That is indeed the same number as you get on the other side. So your answer is again correct. All right, so last example here, example D. So again, I mentioned we were going through all the operations. We looked at addition, we looked at a subtraction problem, we looked at multiplying. So if I look at this example right here, here's the side with my variable. And again, that fractional bar means division. So this would be the operation of division. So to undo it, I'm going to multiply. So I have times 12 on both sides. Please ignore those little boxes, guys. That was just the way that I had to put it in there so I could get them floating. So again, on paper, it's going to be a lot easier. You can multiply by 12. Again, shy away from using the x so you don't get confused with the variable x. You can use a dot. So again, when we are multiplying and using inverses, times 12 and divided by 12 are opposite. So we're going to go ahead and cancel them. We're going to cross them out, and we're just left with the x on the left-hand side, which is exactly what we're looking to do. And then following through with my computation here on the right, we have 5 times 12, which is going to give us the answer of 60. So x is equal to 60. So checking it, again, here's my original equation. We would just be taking out the x. We're evaluating it in a sense, guys. We're going to take out that x, and we're going to put in our answer of 60. So now performing, what is 60 divided by 12 here on the left-hand side? It's 5. And then when I bring down my other number, we get the statement of 5 equals 5, which is true, meaning that we solved the problem correctly. So you can kind of troubleshoot again. If you would have come up here and you would have gotten the answer of, let's say you accidentally added or subtracted or did a different operation than you should have, and let's say you got an answer of like 23, again, you would be able to tell if you were correct. If we would have went down and checked it, and here's my original equation, x equals or divided by 12 equals 5. If we would have taken out that x and put in a 23, we would have gotten an answer that is not 5. It would be something like 1.9, something like that, and that is not equal to 5. So we would know to go back up and check our work to see where we went wrong and be able to correct it. So again, the checking step is very easy for you to do. You can plug this part back in your calculator. You could do one simple operation and determine that you're correct or not. All right. So we're going to do this in class if you're joining us for the live instruction. But again, here's kind of some practice examples we're going to work through. So example number 1. So here's my problem over here on the left-hand side here. X plus 3 equals negative 12. This is just to stop and think to try to help you. So what operation is acting on the variable? So again, if I look at my problem, here's my variable on the left. What operation is there? It is addition. What's my inverse? It's subtraction. And then we're actually going to put that in place. So again, here's my original equation, just rewritten there. We're going to subtract 3 on both sides. That is my inverse, right? And then when you do that, again, positive 3 and negative 3, they cancel, and I'm left with just my x, so it comes down. Performing the computation here on the right, we have negative 12 minus 3, which gives us negative 15. And this last box, we're just going to plug in our answer into where the variable is and make sure that we are correct. So again, here's my original problem here at the top. I'm going to take out the x. I'm plugging in a negative 15. Performing the operation here on the left, negative 15 plus 3 is negative 12. That does indeed equal negative 12. So check, our answer is correct. Taking a look at number 2. So again, here is my original problem. Looking specifically at the side with a variable, ask yourself what operation is going on between the h and the 15. Hopefully you're saying subtraction. Then my inverse, what is my opposite operation that I'm going to use? I'm going to add to get rid of it. So following with this equation, actually see if I can make my pen here a little bit smaller for us. We would again, if you want to draw that little line down the middle, by all means, go ahead. It separates your left side from the right side. So again, my inverse operation of subtraction is or addition. So we're going to add on both sides. Then from there, again, the reason why we're using inverses is so that it cancels and our variable is left all by itself, because that is the goal of solving an equation. We want to figure out what the variable stands for. So if I have a negative 24 and I take away, or I add on 15, you're going to get the answer of negative 9. Okay, and then this is just your space to check it. Again, here's my original equation. I'm going to take my answer of negative 9 and plug it in for the h. Figuring out on the left-hand side, these can be solved and put together. So negative 9 minus 15 more gives me negative 24, which is equal to negative 24. So check that we are correct. Okay, the next one down here. Here's my equation. Looking at the side with my variable, this just, again, you don't have to always write this out. It just makes you stop and think for a minute. So looking at that, the relationship between those two, subtraction. My inverse is addition. So I know that I'm going to use addition in order to solve. I'm going to go ahead and make my lines. I'm going to make them the whole way down since I've got my tool out here. That way it doesn't get confused in with my writing. All right, so switching gears, so we're going to go to the equation here. So again, we said we see subtraction, so we're going to undo it by using the opposite, which we identified as addition. These cancel, they're inverses. So we have y equals 10 plus 7 is 17. So y is 17. That's our prediction. That's our answer. So I'm going to come over here and check it. Again, I rewrote this here for you. Y minus 7 equals 10 was our original equation. We're going to take out y, plug in our 17. 17 minus 7 is 10, which is correct. 10 equals 10. Looking in this next equation, again, here's the side with my variable. The operation I see is addition. My inverse is subtraction. So following through and solving it, we're going to subtract on both sides, subtract the value of 4 so that it cancels. Our variable n there is left all by itself. 7 minus 4 is 3. Now to check, again, we're saying the n we think is 3. So we're going to put in our 3, rewrite the rest of our equation how I see it. 3 plus 4 is 7. 7 equals 7. All right, take a look at this last example here. We have 64 equals 8c. Now in this example, my variable is on the right-hand side. So please don't let that get you frustrated. You are just looking at the side with the variable. So in this case, the operation that you see is multiplication. And the inverse is going to be division. So to follow through with solving that, here's my side of the variable. I'm going to divide by 8. And again, guys, when we're using division, we want to make sure to use that fractional bar, not the division sign. 8 divided by 8 is 1, which is the same as just C. 1C is the same as C, so we can go ahead and cross it out. 64 divided by 8 is 8. So plugging it back into my equation, again, here's where my variable is. So I'm going to rewrite everything how I see it, and I'm going to take out, sorry guys, it looks like a crummy 8, but that is an 8. And I'm going to show my multiplication. 8 times what? 8 times 8. That's what we think our answer is. Figuring out 8 times 8, 64. And guys, if you need to use a calculator for your computations, by all means, go ahead. 64 is equal to 64, so check. We know that we have that last one done. All right, so for your assignments, you're going to see, I've attached an image in the assignment if you need it, but you are looking at page, I believe it is page 8. Let me give it a quick check. Yes, you're going to complete the practice problems on page 8 for your assignment. Reach out if you need help.